Hey guys, so in this video I want to go over lesson 1 for unit 4. So we have our steps already written out for us. First, factor, simplify if possible. If If we are dividing, change the operation to multiplication by keep, change, flip, or keep, change, change. Either way you would like to say it. If we are multiplying the fractions, multiply straight across. Either one, the last step should be to simplify the numerator. Okay, so let's do an example. For number 1, we have multiplication in between, so we are multiplying straight across. So 2 times 4 and 3 times 5. So to simplify, 2 times 4 is 8, 3 times 5 is 15. You have to ask yourself, can we simplify 8 over 15? No. So that is our answer. We did not put it in a decimal form. That is just our answer. So let's do a little bit harder. Let's look at number 3. Number 3, we are having to factor everything first, then see if we can simplify or cancel out anything. So let's factor the first part. And we're going to have a big fraction because we're multiplying straight across. So the first one, is there a GCF? Yes, it's 3. So 3x divided by our GCF gives us x. Negative 6 divided by our GCF, which is negative 2. Then you go on to the next one. Next one I'm looking at is 5x plus 15. Is there a GCF? Yes, 5. So you're going to take your first term, 5x, divided by your GCF, which is 5, and you get x. Next term is 15. 15 divided by your GCF is 3, so you plus 3. Then you look at your denominator. 2x plus 6. Is there GCF? Yes. 2x is our first term divided by our GCF, gives us x. 6 divided by our GCF is positive 3. Then lastly, we have 4x plus 8. Is there GCF? Yes. So we're going to divide each term by our GCF. 8 divided by 4 is our 2. So now that we have completed factoring everything together and we're multiplying straight across, we're going to cancel out any like terms that are in the numerator and the denominator. So I'm asking myself, is there 3 in the numerator and denominator? No. Is there x minus 2 in the numerator and denominator? No. Is there a 5 in the numerator and the denominator? No. Is there x plus 3 in the numerator and denominator? Yes. So we can cancel it out. It is no longer there. So we have 3 times x minus 2 times 5 all over 2 times 4 times x plus 2. So with this, we can simplify it further. So multiplication is commutative, so we're going to do 3 times 5, which is 15, times x minus 2, over 2 times 4, which is 8, times x plus 2, Simplifying this one last time, we can do our 15 times x and our 15 minus 2. Get 15x minus 30 over 8 times x, 8 times 2, so 8x plus 16. And that is our answer for number 3. So let's do a little bit harder one. Let's go to number 10. Number 10, we're going to factor each of these as far as we can. So the first thing we get to is x minus 2. Can we factor anything out from x minus 2? No. So we're going to use this in our big fraction. For the next one, x squared plus x minus 2. Can we factor it? Yes. Is there GCF to take out first? No. Does our a equal 1? Yes. So we can go straight into our big X method. Our b is 1. Our c is negative 2. We want two numbers that multiply to give us 2, but also add or subtract to give us 1. Well, 1 times 2 is 2. We can add or subtract 1 and 2 to get 1. So those are our magic numbers. We always have to make sure, though, that we don't need to make one of them negative or both of them negative. 1 times 2, and I want negative 2. 1 plus 2 to give me 1. Which one needs to be negative to get positive 1? The 1. The 1 needs to be negative to make this true. So if the 1 is negative, negative 1 times 2 gives me negative 2. That is now true. So that means this green, or this denominator of the first fraction, becomes x minus 1 times x plus 2. The second numerator, we can factor this. Can we factor out a GCF? No. Does our a equal 1? Yes. So we can go into our big X, negative 3 and 2. We want two numbers that multiply, give us 2, but also add or subtract to give us negative 3. So you can do your t-table. Well, 2 times 1 gives me 2. So let's try those two numbers. 2 and 1. So I want to ask myself, 2 times 1, I want 2. But I also want those same numbers, 2 plus 1, to give me negative 3. Which one, or both, needs to be negative to get negative 3? Both of them. So that makes it the addition true. If I have negative 2 times negative 1, I also get positive 2. So those are my magic numbers. So in a second, I'm going to use the factored form of the second numerator as x minus 2 times x minus 1. Then lastly, I have x plus 2. Cannot factor it, so it stays the same. So all of this gives me a big fraction bar x minus 2 times x minus 2 times x minus 1 all over x minus 1 times x plus 2 times x plus 2. So I'm asking myself, can I cancel anything out? Do I have an x minus 2 in the denominator? No. Do I have another x minus 2 in the denominator? No. Do I have a x minus 1 in the denominator? Yes. So it is now gone. So then I'm going to simplify this. So x times x gives me x squared. X times negative 2 gives me negative 2x. Negative 2 times x gives me negative 2x. And negative 2 times negative 2 gives me positive 4. Then we have x times x in the denominator. X times 2 gives me positive 2x. 2 times x gives me positive 2x. And 2 times 2 gives me positive 4. We're going to simplify this one more time, excuse me. So we have x to the first and x to the first, so they are like terms. So we do have to combine like terms. Same thing in the denominator. We get positive 4x plus 4. So this is our answer for number 10. So lastly, we have number 9. So when we have division, we have one extra step involved. So if I just gave you a fraction, let's say 1 over 2. Instead of saying 1 over 2 or 1/2, what does this division, or I just gave it away, I'm sorry. What does this fraction sign mean? Division. So if I wanted to rewrite this original problem for number 9 without using this second or this middle fraction line, what would it look like? So I'm going to write my x plus 2 all over x squared minus x minus 6 divided by, because I just changed the fraction bar, x squared minus x minus 6 all over x squared plus 6x plus 5. So if we go back to the top corner of our notes, if we are dividing, we have to change the operation to multiplication, then keep, change, flip, or keep, change, change. So I like the words keep, change, change, because that's what you're going to do. So we are keeping the first parentheses, or the first fraction, the exact same. So x plus 2 all over x squared minus x minus 6. You are changing the division to multiplication, and then you are changing the second fraction by flipping it. So now the x squared plus 6x plus 5 is in the numerator, and the numerator is now the denominator, the x squared minus x minus 6. And then you are factoring these just like we did with the last few. So for the x plus 2, you cannot factor it anymore, so that is how it stays. For the x squared minus